In this demonstration, we see that the common of the digital voltmeter is connected to a stainless steel container in which there is silicon sand of very high resistance, and on the top there is a highly absorbent cloth, and I have folded in some artifacts made of different materials. You can see that at the present time there is a voltage of 3.73 millivolts difference between the potential of the reference or earth contact electrode and the metal of the container. I will not move the connection to the metal of the container, so that is in fact for this demonstration the reference potential. That is connected to the common of the meter, and the meter therefore displays all potentials in relation to that potential. The voltage is a potential difference. Now, I will move the copper to copper sulfate electrode, and you can see that when I vary the pressure, the reading varies, and that is because the measuring circuit includes a resistance between the copper sulfate electrode and the pseudo grounds that we've made here. As I move the electrode, you will see that the voltage changes. It is now 3.58. If I move it slightly, it goes up to, it'll go up considerably, but it hasn't go at the moment. No. Now I move it again, and it is 3.92, 3.82, 7.78, 3.57, 4.52, 3.24, 2.87, 3.20, and let's go back along to here, to this region, 4.03, stick it back where we first had it. Now, if this was a fixed reference potential in this demonstration, because this connection to the tray has not moved, then this voltage will be the same wherever I put the reference, the copper sulfate electrode, because a reference electrode or a reference potential means that that is the stable potential against which we measure or compare the unknown or variable potential. In cathodic protection reporting, the inference is that the copper sulfate potential is fixed, and that therefore the other side of the meter is the variable. But the other side of the meter in our CIPS and maintenance pipe to saw readings is constantly attached to the same metallic block of the whole of that section of the pipeline. The variation in the voltages that we record are because we move the ground contact electrode, the copper sulfate electrode. When you move that, you get a variation in the potentials. Now, this variation can be due to a great variety of electrical flux in the ground itself, and we have to interpret the voltage readings to find out what is happening to the corrosion status of our pipelines. So, using close interval potential surveys and pipe to soil measurements, we have not got a baseline or datum for our calculations. We have not got a fixed zero for the beta to refer to, so that we can calculate all the readings against a unique and fixed potential.